We are at Clemson University's Coastal Research and Education Center near Charleston. With me is Dr. Richard Hassel, who is our State Extension Vegetable Specialist. Dr. Hassel, you're doing work now on grafting vegetables.
That's correct.
And also with us is Shauna Daly, a research assistant, and I think you're going to show us how to do this.
Yes, I'll be demonstrating the Japanese top graft hole insertion method.
Dr. Hassel, why are we doing this now? It looks like a lot of work.
Well, we're getting into grafting as an alternative for soil fumigants, or grafting as a method of controlling soil-borne diseases.
Is that something that our growers face? Is it a big problem for them?
Our growers are now facing the problem with soil-borne diseases as a major concern because we no longer have the availability of soil fumigants.
You are specializing in work on cucurbits, and what are cucurbits and why is that important to South Carolina?
Well, cucurbits are a group of vegetables consisting of watermelons, melons, and cucumbers. And they're grouped into a class of vegetables called cucurbits.
And we've had the watermelon queen on Making It Grow. That's a big crop for South Carolina.
Yes, we're one of the leading states in watermelon production.
So things you can do to improve that will help our farmers.
Most definitely.
Do you think, Shauna, that you could start demonstrating how this goes and we can talk some while she does that about
Sure.
what you're using for the top and the bottom?
Right.
So this looks like a pretty vigorous plant. What is this?
Right. This is what's called an interspecific hybrid squash. It's a cross between two different types of squash, Marshata and a Maxima, or basically a butternut squash and a turban type of squash. And it was bred specifically for the disease package. But along with that, this rootstock is very vigorous. And so the quality of transplant that you're growing with this really is you're looking at the root system that's going to produce. Not only does it have the resistance to a disease package, but it also has the added advantages of a more intense root system.
And you are nicking out one of the cotyledon leaves and that first true leaf, is that correct?
Correct.
You said that you don't want to have that true leaf there because it might outgrow or come back?
Right. Well, one of the problems with grafting is that you've got to make sure that you remove all the meristematic tissue like she has here. In other words, the meristematic tissue is the growing point that you see, and you want to get as much as possible of that as removed as possible. The main problem, that's why you want to graft these when the very first true leaf, you can see it for the very first time. That's the ideal stage to grafting.
All right.
But you wait a day, it'll get bigger and bigger, and it's less chance of removing that tissue.
And then this is the watermelon that we're going, the sign
Right.
that will become the top.
Right, the reason it's called sign, this is the top portion. Okay, this is what the crop that we actually want. This could be watermelons, this could be melons, this could be cucumbers. Mm-hmm. Okay, and we grow those differently than we grow these here. We try to match them up at the same developmental stage.
And so you have made a slant cut on both of these.
Right, we're looking at a cut which would be about a 30 to 40 degree angle on both of them. And then we're going to try to match them up. You notice one is bigger than the other, so if we match them up on one side or crosswise, we're more likely to put in contact with the tissue that's needed to heal.
Mm-hmm. So you're going to push those together, and then you've got a tiny little clip that will hold those two portions together,
Right.
making contact.
It's basically what it is, it's a miniature clothespin clip.
It is like a little clothespin.
Right.
And I was so surprised. I thought that you would use the root that was already here, but you're going to root the stock, the
Right.
bottom piece as well.
Right, exactly. Because the reason we're doing that is the root system in these takes a lot of energy to maintain this root system. And if we don't have that root system on, then it's more likely to heal the graft that she did. And then as it heals, then it will start producing its own roots again. And so that's the reason we've got to have this cotyledon leaf on, because that's providing the food for healing and rerooting.
All right. Dr. Hassel, that's just one of the methods, so you said there's another method that's sometimes used for different purposes.
Right, there's basically two methods, and I've showed you the first one. The second one is called the hole insertion graft, and that's basically used in Japan. And Shauna Daly will show you how that's done now.
So with the hole insertion graft, we use the same interspecific hybrid squash rootstock, and we'll take a toothpick and just...
You kind of flattened it. Looks like you...
Yes, we flattened the
squished it.
toothpick
All right.
out with a razor blade, so it's kind of a flat area there.
Chisel.
Mm-hmm. And then we'll send this right down into that meristem area and poke it all the way through the rootstock until it's kind of sitting out on the other side. You can kind of see it poking a little bit right there. And we'll let that sit for a second. And then we'll take our scion again, this watermelon, and we'll cut an angle the same, about 30-40 degrees. Then we turn that cut 90 degrees and cut it again so it's very sharp and it can fit in that toothpick hole.
So you've got a point on it now.
And then we'll take out our toothpick and insert that scion right into there. If I had made a longer cut, you'd be able to see it kind of sticking through there.
And no clamp
No
needed, no
clip.
clothespin.
Yes.
Now, why is one preferred over the other, Dr. Hassel?
Well, they prefer that one because in their country they have a lot of wind.
Oh.
Okay, and with this type of graft,
The first one.
the first graft, the one called leading graft, when you take the clip back off, has a tendency to be weak right there, and the wind comes, and it'll have a tendency to break off.
Oh.
Okay, whereas with this one here, it's down through the middle. It heals all around, and this one is not affected by the wind.
It's more solidly affixed.
Right. But this one is more difficult to do. It's more of an art than this one, and it takes a lot of work to get this one to work.
Now
on a consistent basis.
we've got these, and they don't have any roots on the bottom, and so moisture and humidity is going to be pretty critical. How are you going to treat these?
Right. After we graft them like this and then put them in fresh soil like this to root, then we'll put them in a healing chamber. Okay, and this healing chamber is basically controlling the humidity. Temperature needs to be at least above 70 degrees within the healing chamber, but the humidity is the most important. For the first 48 hours, we like to have it close to 100% humidity as we possibly can. That makes sure that the plant is actually it's not transpiring. It's not having to rely on any type of moisture to survive. The humidity is high enough that it won't wilt.
Dr. Hassel, I think this is kind of the finished product. This has been in the healing chamber and then given the slow exposure, bringing it out into the greenhouse. And what a beautiful rooted cutting you have.
This is rooted. It's now healed. The clip can be removed. It has about another 3 or 4 days within the greenhouse itself, and then it's ready to go to the field.
And as fascinating as this is, it sure looks like it'd be hard for a farmer to do this and get 100,000 cuttings to put out, transplants to put out and make money. So how are you addressing that?
Well, we're working very closely with the transplant producers that will provide plants for these growers. And that's what Shauna's project is involved in, working with those growers.
And what are you doing?
I'm looking at methods of treating this rootstock to try and make sure that we can control that rootstock regrowth to eliminate that meristem so that we can put that scion on it and it won't have any regrowth problems.
Dr. Hassel, this is not important only to very large producers, but also some of the smaller growers.
Correct. That's very true. We can adapt these, especially in the tomato industry. Tomato growers now can purchase these in local stands now that are grafted. And it's important because a lot of our consumers like the old traditional type of tomatoes, the old heirloom tomatoes. And those are very susceptible to every disease known in the book. And this way, they can graft the tomatoes onto a rootstock that is resistant to everything, and then they can grow a nice quality tomato.
And you have a machine that can, with the flip of a switch, graft both cucurbits and tomatoes. Tell me about this wonderful little robot.
Right. We purchased a robot that we're using to modify a little bit with some of the new techniques that we're doing. But this robot involves the arms and hands that we usually use in grafting, only the machine does it. And it has 2 people that feed the material in. And then it has a series of arms that cut the angle for the scion, or the crop that you're actually grafting. And it also cuts the rootstock material, and then it moves those materials together, puts a clip on them, and then drops them on the conveyor belt. And then all that we do now is just stick them in the soil. And they come out basically looking like this. It's only possible, although, with the one cotyledon method.
Dr. Hassel, we thank you for sharing your day with us, and I will speak for the extension agents. If people have questions, I hope that they will call their local extension offices for information. But I would like to thank you as a consumer for the work that Clemson University and you are doing here to improve the economic outlook for South Carolina farmers.
Well, thank you very much for having us.